Welcome to this EGR 185 video tutorial. In this tutorial, I will be showing you how to use timers to generate delays and eventually how to make a state machine using timers. We're going to be simulating a stoplight. So we have LEDs moving from green to yellow to red. So what is a timer? You can think of a timer as a sort of internal pin that goes from 0 to 3.3 volts and back down again, over and over and over. The timer in your Arduino is 16 megahertz, which means it goes from 0 to 3.3 volts, or from logic 0 to logic 1, 16 million times per second. So let's look at the basic code we have here. First of all, I have macros. If you haven't seen these before, all it does is it replaces anywhere that has these letters, green pin, with the number 2 defined here. Same with yellow pin and 3 and red pin and 4. You can see here I have set up the serial port. I've also set up the pins. Green pin is output, which remember this is replaced because it's a macro. It's replaced with the number 2. This one's replaced with the number 3, etc. Then in our main loop, I digitally write the green pin high, pause for 1 second, and then write it low. And I do that with the yellow pin and the red pin. So let's get rid of some delays. First thing we're going to need to do is get our variables. These have to be unsigned long because that is what the function we're going to use returns. So we'll have current time, and we're going to right off the bat use this millis function to grab the current time on the timer. So what this does is while that timer is oscillating up from 0 to 1, 0 to 1, 0 to 1, this is recording how many times it does that in 1 millisecond. And then it returns the milliseconds that have been counted since the board was turned on. The next one we're going to do is unsigned long previous time. And we're going to set that equal to current time. Now I want you to get in the habit of doing this because this is what we're going to do in our state machine later. So for now, we're just going to play around with the green pin. So let's get rid of these guys. So during the loop, we want to constantly be updating our current time because we want it to be the current time. There we go. So every time our loop runs, it's checking what time is read from the timer. So now we want to compare that to the previous time recorded. So we're going to say if current time minus a previous time that was recorded is greater than, and we'll say 3,000, so that'll end up being 3 seconds, then we're going to turn the green pin on. So let's go ahead and clean this up a little and upload. If I did this right, the green pin should turn on for 3 seconds, or turn on after 3 seconds. Okay, I'm going to press my little reset button. Now it's off, and 3 seconds later, it turns on. Great, so now we can turn an LED on. That is always a good thing. Now we have to turn the LED off. So we're going to use digital read to check and see whether the pin is on and off, on or off, and then change it to be the correct, or whatever we want it to be, on or off. So inside of our current time, we're going to check, we're going to grab the value. So let's get another variable, and we'll call it LED val. So let's grab that val. We do that by calling digital, oops, can't type today, digital read, and we want to read the green pin. If our LED val is low, that means the LED is off. So we're going to want to turn it back on. Green pin high. Otherwise, our LED val is going to be high, and we want to turn it down to low. Finally, we're going to need to set our previous time to the current time. So this is why I wanted you to do that at the very beginning. So what does this do? This means that, let's say the current time was 3000 and the previous time was 0. So 3000 minus 0 is 3000. We'll say this was current time was 3001, just for the sake of making this simple. 3001 minus 0 is 3001, which is greater than 3000. Yay! So we get to execute what's inside the if statement. We turn the LED, whoops, just realized that shouldn't be there. We check the LED val. We then look and see if it's low, and if so, we turn it on. Otherwise, we turn it off. Next, we set previous time equal to 3001. If you remember, that's what our current time was. Now we exit the if statement and we go back up to our loop. And what's the first thing we do? We check current time. Well, current time is now 3002. What is 3002 minus 3001? Well, it's 1, definitely not greater than 3000. Well, we keep doing that over and over until another 3 seconds have passed. And boom, now this is 6001, and this is 3001. Hey, we've got 3000. It's greater than 3000. So now we get to read our LED val again and go through this sequence. So what this code should do is every 3 seconds, it should toggle the green LED on and off. Let's see if that happens. You can see that about every 3 seconds, the LED turns off and then it turns on again. Now we want to do this with a state machine. Our state machine is going to be very simple. We're just going to have red, yellow, and green. And we're going to go around in a circle with, we'll put our init state over in a weird spot over here, going straight to green, and then just going around in our circle forever and ever. So an easy way to record our state machine states is with enums. And enum is like your own made-up number system or alphabet. We type enum, and then we give it a name. We're going to call these stoplight states. Then we got curly braces, and you should always just put a closing curly brace and a semicolon just so you don't forget later. And then you get to put in your made-up values here, or whatever you want. So I'm going to say my states are green, yellow, and red. And this can be whatever I want. It's basically my own made-up special set of values. Now we're going to need to declare our state. So I'm going to say enum stoplight states. So that's the name. That's like if I wrote int or char. And then I'm going to give the value a name. So we'll just call this cur state, and we're going to make it start at green. So this was just like if I had written int I equals 0. int is enum stoplight states, I is the equivalent of cur state, and 0 is the equivalent of green. So it's not just like it, because obviously this is going to be different than 0. Don't equate those two. I'm just showing you how the naming convention and the nomenclature work. Great. We have our states, we have an instance of our states, and we also already have, let's go ahead and put these up where they probably should have been before, right above our setup. We're not going to need our LED val this time, but we have our current time and our previous time. Now, again, current time, we're going to change, or we're going to keep current time, but we're going to change previous time. We're going to call it time since state change. That is a hint for what comes later. So anytime you see a state machine, you should immediately think a switch and case statement. So a switch and case statement, hopefully you've seen these before. They check one variable, and then based on whether or not that variable is something in a case statement, it does what it says in the case statement. So we're going to check the variable cur state. We get curly braces. And in the case that our cur state is equal to red, we're going to do some things. And then we're going to break. Every case statement needs a break. So case red, oops, we're going to do case green first because that's how I defined it above. And we're going to do case that the case is yellow. And again, our break statement. And finally, we're going to have a case for whether or not things are red. And break. The question is, what do we do in the case where we have our green state? Well, I like to write it out in comments before I write out the actual code. So let's write some comments. First of all, we know if we're in the green state, we want the green LED to be on. We want the yellow and red to be off. And then we want to be able to change states. And we'll change after 500 milliseconds. And we're going to want that in every state. Now you notice I'm copying and pasting things. That should flag in your mind. That should mean, hey, I should write a function instead of having to copy and paste all this. Well, I'm not going to write functions right now, but please check out my other video if you want to learn more about functions. So in this case, yellow LED is on, and green and red are off, and in this case, the red LED is on, and yellow and green are off. Great. So this should be pretty easy, right? We want it on, digital write, green pin, high. And then we want these off. So low, whoop. And this should be red, and this should be yellow. Super easy. The hard part is changing states. So we can do something similar to what we did last time. We'll do if cur time minus time since, I gotta remember what I said that, state change is greater than 500, do some things. What do we want to do? Well, first of course, we want to change the states. So we'll change cur state to yellow. But now we need to make sure that this all happens for every state, right? So we want to update time since state change because we just changed the state. So time since state change is what? Well, the state just changed, so we want it to be the current time, and we get the current time using milliseconds. The other thing you can do is equals cur time. Because we already got the current time way up here, we don't really need to call that milliseconds again. Okay, so that is how we change states. I went ahead and changed the rest of the states, so you can see now case yellow, the yellow pin is high, and red, the red pin is high. And then the rest of them I also changed the current state so that it changed to the correct one. So let's look at what this looks like. As you can see, they're moving at about a speed of half a second. So every half second it changes, which is exactly what we were hoping. So let's just go through this code one more time. We get the current time in milliseconds. Then we check the state. Let's say the state is yellow. So we jump down to this yellow case. We write the yellow pin high. We write the green pin and, whoops, red pin low. And then we change, and then we check the current time. Now, this is going to keep on going over and over until it finds out that the current time, which remember we checked all the way at the top every time we loop, is great or is 500 more than the time since the last state change. If that happens, we change the state and then we update the time since the state changed because, well, our state changed. And that keeps on going over and over. I hope you've enjoyed this video tutorial. Sorry, this one was a little long, but I wanted to include both how to use the timer and how to use it in a state machine. Please reach out to us with any questions. We're always here to help.